Cool. So we have talked about command substitution. We have talked about arithmetic expression. And now we are going to talk about the next syntax you should be aware of. This one's a little bit weird. You may have seen it, but it might be a little bit confusing. I'm going to explain where you're going to want it. It is process substitution. This is not command substitution. This is process substitution. The syntax for command substitution is $parens, and then you put the command you want in there. The syntax for process substitution is very similar. It is a less than sign, and then parentheses, and then the command you want to run. So it still takes command. Technically speaking, you can also have a greater than here, and it will reverse the way that it works. This is a very specific syntax for a very specific use case. I find this one to be used more often. I'll explain the differences as I go through, but I'm going to focus more heavily on the less than variant of it. But let's dive into it. So let's go ahead and make our script process substitution. Make sure I can type. Listen, talking and typing is not as easy as it looks, okay? It's a skill and I've honed it. That's why I am amazing at what I do. No, I'm just kidding. That's why my brain like shuts off when I'm talking, when I'm typing. All right, enough joking around. Let's lock in here. All right. So let's go ahead and do what we have done before, which is we're going to write a little script to get some words out of user shared dict words, and we're going to use grep to find words that have a D in it, anywhere in it. So to do that, we're going to use grep, we're going to grep for D, and we're going to grep in user share dict words. And that's how we're going to do it. That's how we're going to get every word that has a D in it. That's great, but let's do some processing on it with bash. So we have process substitution. Let's go ahead and give it a chmod plus X before I forget. Let's vim that file, and there we go. So we're going to grep D and user share dict words, but we do want to process this information, so we want to store it. Let's store it as a variable. So this variable will contain all of the words that we found that are separated by new lines. We're going to read the entire thing into this variable. This will be read completely into memory. Our RAM will hold this for us. So I'll talk about that later. I might be spoiling a little bit, but let's go ahead and go forward with this. Let's say we want to count how many words are in that file. Now, real quick, before I continue, I would be remiss not to mention this. With grep, I can give it a flag -c for count, and there we go. There's our answer. Stick to the tools that work. If you're just trying to get the count of something like that, use the built-in tool, okay? But we're going to do this in bash because I'm teaching concepts here that can be applied to more than just a specific situation, something that can be applied more broadly, and it gives me an excuse to talk about all the fun syntax we have here. So let's go ahead and let's set I equal to 0, and we're going to count every word that we see. So we're going to do for word in $words do. Notice that we're not quoting it. This is important. This is on purpose. We are not quoting it on purpose, and I will explain why. And then I will also talk about, don't worry, what I'm writing here, you should not be writing this. This is the wrong way of doing it, but we're going to iterate and show the better way of doing it. So we're going to echo the word that we saw, and then we're going to do I++. So we're going to increment it, and then we're going to say done. And the last thing we can do here is we can say found $I words. So it should print all the words that we saw, and then at the bottom it should say how many there were. Correct? So let's go ahead and run this. Okay, that worked pretty fast, and we found 60,155 words. I believe that's exactly what grep showed us. Cool. So that works. This code is working exactly how we want it to, but let me give you a little secret here. If you find that you're not quoting this thing in a for loop, and that makes it work, then it's probably wrong. Like, you really shouldn't be relying on this because you're using word splitting here in bash. It's extremely powerful and you can use it if you know what you're doing, but there are better ways to go around doing this. Like I said, I just use it and it works just fine because I know what my input is. I know what user shared dict words look like. If you know your environment, then go ahead and use it. But if you want to make your scripts resilient to any environment or to any kind of input, if you find that not quoting your variable expansion makes it work, then that's a sign that there's something that needs to be fixed with your script. That's sort of my rule of thumb that I operate on. Because if I were to quote this, what happens now? That's not the right command. It printed everything, and it said it found 1 words. So it quoted the whole thing, and it found 1 word. That word just happened to be a very large string with new lines in it. So not exactly what we want, but there are some alternative syntax here. I'm going to teach you a new thing that I haven't talked about yet as I go along. So let's just make some changes to this. Instead of using a for loop, we are going to use a while loop. We're going to do while read -r so we don't mangle any backslashes, word do. So we can get rid of that, and now we have a while loop, and this is going to read any word. The problem is this is going to read standard input. We need to tell it to read this. We need to tell it to read a variable that we have that is separated by new lines. So how do we tell it to read a variable? We're going to use something called a here string. H-E-R-E, as why don't I just type it out? There you go. That's what I'm saying out loud. There might actually be a space here. Now, here strings are super nice because they let you pipe data into a command that already exists in a variable that you have. So you may have seen we could do this, and then we could put the name of a file here. So we could put user share dict words here, and that's totally fine, but we want this grep to run, okay? So we can't just put this file here. We want that grep to run. So instead, we can use this syntax. This is gonna be gnarly, but get ready for it. Triple less than. Now that we've done that, we can give it the variable here. That is called a here string. It reads a variable that is already set in bash. The triple less than is the notation for that. So read will get this information over and over again continuously until it's exhausted every word that it's read that's already gone through the grep. So I run that. As you can see, it's a little bit slower, but it works, and we found 60,155 words. So that's awesome. That's great. So this is a here string, and we haven't actually done any process substitution yet, even though that's what this section is about. So let's go ahead and rewrite this again, because you may have noticed that we had to read this whole thing into memory. And that's not great, because 60,000 lines of a file, that's fine. I probably have enough RAM for it. But what if it was, 60 million or something, or 600 million, or 600 billion lines? What if it was an unlimited amount of lines? That doesn't really work if we're trying to total them. But I think you get my point here. We can do this better. We can do this in a streaming fashion. Instead of having to let this line block until it's read the entire file, we can stream that data into the while loop. And I'm going to show you how to do that now. So to do that, we're going to move this line down here, and we're going to get rid of the command substitution. So we just have that grep, and then here's what we're going to do. This is pretty wild. We're going to join these two lines together. I use capital J in Vim to do that, and then put a pipe character here. This is valid. This is totally valid, and it works just fine. You can pipe into a while loop. If you do it that way, you have to get rid of this here string, because we didn't define that variable anymore. So we have this syntax, totally valid, totally works just fine. We can grep for d out of user share dict word, and we can pipe it to while read. We get the word variable, we echo the word variable, and we do I++, and we run it, and it should give us the total count. So you ready for this? It goes through it, and what is this? That didn't quite work. That's kind of weird, right? Well, this is similar to what we saw before. Remember how I talked about a subshell? Anything that's not to the left of the first command here, so anything to the right of a pipe, is being executed in a subshell. This is in a pipeline. So this while read line is working, and it is incrementing I. I is incrementing in its process. And then when its process dies, it's gone. So anything to the right of this pipeline doesn't stay in effect once we're done with it. Once we get to this line down here where my cursor is, I is set equal to 0 because it never got modified in the global scope like that, or in the main process or the main shell. How do we get around this? Well, finally, we can use process substitution. Hey, look, we're finally getting to the thing I've talked about. I managed to talk about 10 different things because we had to kind of work our way there. How do we do that? Well, let's go ahead and get rid of this. I'm just going to trash that all. And now this reads from nothing, so technically it would read from standard in. Let's have it read from a file. And the file we would give it normally would be user share dict blah, blah, blah. We don't want to do that. We want to have it read from a process. So we want to substitute a process, and that's what process substitution is here. So we can use this syntax. We use less than first here on its own to say we're reading from a file, and this syntax gets replaced with a file, and that file can be consumed as though it was like the command that's running inside it. Might be a little bit confusing, but I'll show you what I mean. We can grep for D in user share dict words. We put that there, and now it might look weird. I mean, it does look weird, but if we run it, we do this, look at that. We still get found 60,155 words. So that is process substitution. That allows you to put a process in this file. This gets replaced with the name of a file. I think technically underlying it's like a pipe or something. That's very specific to how your OS works, but it's super convenient because just to illustrate this concept, to bring it home, I could say echo uname here, and that is command substitution. If I did this, just prints a file descriptor. That's just a file descriptor. I can't echo it. I have to cat it because it's like a file. To read a file, you would use cat in this example. I can cat it. Of course, I can also less it. Kind of weird. I don't know why you do that. Oh, it's not a regular file. Oh, that's cute. Let's do less minus f. Hey, that works. That's awesome. I didn't know less prompt to do if it wasn't a regular file. That's kind of nice of it. So yeah, there you go. That is what process substitution does. You, as a programmer, You almost never need to be aware of the fact that this is the underlying thing. That's just some like specific implementation details of how bash works with your operating system to pass this data along. Most likely it's going to be a pipe that was created in the bash process that's given to your script. Yada, yada, yada. You don't have to worry about that. You get to treat it like a file. So treating it like a file means I can give it after a single less than sign, which expects a file. So this whole thing gets turned into a file that I can read. And what's in the contents of that file? The output of grep d user share dict words. The beautiful thing is this could be a slow command and it doesn't matter. This while loop starts processing immediately. It does not have to wait for the whole thing to be loaded into memory. It can do it in a streaming fashion. That is amazing. However, there are some caveats with it. Because we're not reading the whole thing into memory, because we're not waiting for grep to finish before we start processing the data, we don't have the exit code of grep. This is important. We don't know if grep was successful or not. If grep was given a bad file, we can't easily detect that. Now our script will break, but look at that. We get no such file directory there. We can't easily detect that that's the case. So just be aware of that. When using process substitution, it can sometimes mask the error codes. It can mask the return code. So make sure you're using it with something where it makes sense that you were using it like that.